For almost 4 centuries, the Great Red Spot has churned across Jupiter, a vortex larger than Earth. Yet, within our lifetimes, it may vanish forever. Imagine a storm so massive that 13 Earths could fit inside its swirling eye, its winds roaring at 640 kilometers per hour, outpacing any hurricane we have ever recorded on our own planet. We have watched it evolve from the crude sketches of school children to the crystal-clear images sent back by the Juno spacecraft. And now the storm is shrinking, its crimson hue fading, its boundaries tightening. What does it mean when a feature larger than a continent simply disappears from a world that has never known a solid surface? Jupiter itself is a realm of extremes. It holds 2.5 times the mass of all the other planets combined, a colossal sphere of gas and liquid that defies our everyday intuition. Within this giant, the Great Red Spot has persisted as an anti-clockwise anticyclone, locked between 2 opposing jet streams, as if caught between the gears of an invisible machine. This delicate balance has allowed it to survive for centuries, but recent observations reveal a steady decline in size. In the 19th century, the spot spanned nearly 3 times the diameter of our planet. Today, it measures only about 1.3 times that width, and its shape has become more irregular, its color shifting from a deep scarlet to a muted brown. The mystery deepens when we consider historical parallels. In 1665, the astronomer Cassini reported a permanent dark spot on Jupiter that later vanished without a trace. Could we be witnessing the final chapter of another such phenomenon, one that will slip away unnoticed by future generations? Even Neptune, a distant ice giant, lost its own great dark vortex in less than 5 years after it was first observed in 1989. These disappearances remind us that planetary atmospheres are not static canvases, but ever-changing tapestries. Studying the Great Red Spot does more than satisfy curiosity about distant worlds. It informs our understanding of fluid dynamics on a scale impossible to replicate on Earth. The insights gained have been applied to model atmospheric blocking patterns that cause extreme heat waves and cold snaps on our own planet, phenomena that directly affect agriculture, energy consumption, and human health. By deciphering the mechanisms that sustain and eventually dissolve such colossal storms, we improve our ability to predict and mitigate the most severe weather events that threaten societies worldwide. As we contemplate the eventual fading of this iconic storm, we are reminded that the cosmos is in constant motion, that every structure we observe is temporary, and that our brief window of observation is a privilege. If this glimpse into the vanishing vortex has sparked your curiosity, hit that subscribe button and join me as we continue to explore the hidden forces shaping our universe. Imagine standing on a quiet hill on Earth, looking up at a night sky that once glittered with a familiar scarlet swirl on the face of the gas giant. In a few generations, that mark may be nothing more than a footnote in an old astronomy textbook, a relic of a time when humanity could still point a modest telescope toward Jupiter and witness a storm larger than the planet itself. The loss of the Great Red Spot would not merely be a loss of a visual marvel. It would be the erasure of a natural laboratory that has taught us how rotating fluids behave under extreme conditions. Without that laboratory, our models of atmospheric dynamics would lack a crucial benchmark, and the subtle connections between distant planetary weather and the patterns that shape our own climate would become more opaque. Consider for a moment the broader tapestry of planetary atmospheres. The disappearance of a massive vortex on Jupiter mirrors the rapid fading of the dark storm on Neptune that vanished in less than 5 years after its discovery. Both events underscore a fundamental truth. Planetary weather is not a static backdrop, but a living, breathing system that evolves, collapses, and reforms on timescales that can be swift compared to human history. When we study these transformations, we gain insight into the mechanisms that drive atmospheric stability, the thresholds that trigger collapse, and the energy exchanges that sustain such colossal structures. Those insights ripple outward, informing our understanding of exoplanet climates, of how alien worlds might redistribute heat, and of the potential habitability of distant suns. Yet, the implications stretch even further. The very fact that we can observe the gradual shrinkage of a storm that has persisted for centuries tells us that the universe is not a frozen tableau, but a dynamic stage where even the most massive features are subject to change. This awareness invites a humbling perspective. The grand narratives we construct about the cosmos, about the birth of galaxies, the rise and fall of stars, are all part of an ongoing process of emergence and decay. In the distant future, when the universe has expanded beyond the reach of our current instruments, the sky may be a dimmer canvas, stripped of the vivid markers that once guided our curiosity. The great red spot, in its eventual disappearance, becomes a symbol of that inevitable fading, a reminder that the window through which we glimpse the universe is both precious and fleeting. What does this mean for us, the observers perched on a small blue world? It means that the responsibility to document, to analyze, and to share these cosmic stories rests heavily upon our generation. Each image captured by a spacecraft, each data point logged by a ground-based observatory, each thoughtful interpretation we craft adds a thread to the tapestry of knowledge that will outlive the very phenomena we study. By preserving the record of the Great Red Spot's evolution, we ensure that future scholars, perhaps living in a time when the storm is no longer visible, can still learn from its legacy. In that sense, the storm's decline is not merely an ending, but also a catalyst for deeper inquiry, urging us to look beyond the visible and to ask what other hidden forces shape the universe. As we draw this exploration to a close, let us pause to feel the weight of this moment. The Great Red Spot, a vortex that has survived longer than any human civilization, is now on the brink of vanishing. Its story is a testament to the impermanence that defines all cosmic structures, and it challenges us to cherish the fleeting wonders that the universe offers. In the silence that will follow its disappearance, we will hear the echo of countless questions. How will other planets adapt? What new patterns will emerge in the wake of its absence? And perhaps most profoundly, what does this teach us about the transitory nature of our own existence? If these questions stir your imagination, if you find yourself yearning to uncover the next hidden secret of the heavens, stay with us. Share your thoughts in the comments below. What do you think the loss of the Great Red Spot will teach future scientists? Which other celestial mysteries would you like to see explored? Your insights become part of the conversation that keeps the spirit of discovery alive. Remember, the cosmos does not wait, and neither should our curiosity. Subscribe, like, and keep the dialogue going, for together we can continue to illuminate the shadows of the universe and honor the fleeting brilliance of the storms that shape it.